Alright, so we're going to look at translating verbal expressions into variable expressions. And I'm going to start by going over some the four most common phrases you will hear in mathematics and science. So something like the sum of A and B means you are adding A and B together. The difference of A and B means you are subtracting A and B. The product of A and B means you are multiplying A and B. And the quotient of A and B means you are dividing A and B. And you'll notice these all have kind of the same setup. The blank of this and that. And is where the word and is happening is where that operation occurs. I also want to go over a few phrases that can be kind of tricky for students until they get used to them. First one, A more than B. Well, more than means adding to it. How you translate this is B plus A, not A plus B. You start with B, and then A number more than that is you add an additional A units onto it. A added to B, same idea. You add A onto B. Now, if you write A plus B or B plus A, because of addition is commutative, order isn't really that important. But you want to get in the habit of translating these accurately. So when you run into a problem where it does matter, A less than B means B minus A, not A minus B. If you write A minus B, in this case, order does matter and you would get marked off. You wouldn't get the right answer. A subtracted from B, same thing, is B minus A. So be careful of these phrases. Now notice on the first set, it went in exactly the order we set, so you don't always flip-flop. There's just certain ways of saying things. This is a problem with the English language more than the mathematics. So let's look at some problems. 6 more than twice a number is equal to the sum of the number and 12. Find the number. So start off, this first example, we'll split it up into steps. So 6 more than twice a number. We just said 6 more than something means you start with that other thing and you add on 6. So 6 more than twice a number is 2 times a number, that would be twice, and then 6 more than that you'd add 6, is equal to, equals. And remember, sum refers to addition, so you're going to add the number you just referenced and 12. So we're going to add x plus 12. And now we're just going to solve this equation like we have done in the past. So both sides are already simplified. Let's get it so there's only one x on one side. So I'm going to subtract x from both sides to get rid of the x on the right-hand side. That'll give me x plus 12. Now I just need to isolate the x. So to get rid of that plus 6, I'm going to subtract 6. X equals 6. And if you think about that, if you double 6, you have twice 6, you'd have 12. If you add 6 to that, you get 18. And then if you take 6 and add on 12, you also get 18. So yes, 6 is the correct answer to that problem. Other types of problems, and you'll do a whole bunch of different translations of equations in this format. But another set of problems we're going to look at are consecutive integers, whole numbers, or natural numbers. The setup is the same through all of these, and I'm just going to stick with integers throughout here. But everything I'm going to talk about applies equally to whole numbers and natural numbers. The difference is what kind of answers are valid. Natural numbers start at 1 and then go 2, 3, 4, 5, 6, 7, 8, 9, 10. Whole numbers start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for either of those, if you got negative answers, they would not work. But integers can be negative, so positive or negative values. Consecutive integers, and again, this applies to whole numbers or natural numbers. If you look at consecutive integers, we see that they are 1 unit apart. So if I start with the first number, the next number would be 1 more than that. And then the next number after that would be 1 more than the last one, which would be 2 more from where I started. So you're always referencing the starting number. So 1 more than the starting number, 2 more than the starting number, 3 more than the starting number, and so on. Consecutive even integers, so you started a number, the next even number would be 2 more than that one. And then the next even number would be another 2 more than that. So 4 more than where you started, or then 6 more than where you started, and so on. consecutive odd integers, well, if even numbers are a number plus 2, a number plus 4, a number plus 5, or a number plus 6, the odd ones would be the same thing. A number plus 2, a number plus 4, a number plus 6. So sometimes that throws people off because they see 2, 4, and 6 and they think those are even. But remember, these are values we're adding to the number, not the number itself. The number itself isn't 2 or 4 or 6. It's 2 being added to a reference number, 4 being added to a reference number. So kind of an example to kind of show you how this works. Let's say I looked at these 6 numbers, 11, 12, 13, 14, 15, 16. And I said, let's look at the odd numbers. Well, the odd ones are 11, 13, and 15. Notice 11 is 13 is 11 more. 13 is 2 more than 11. 15 is 4 more than 11. So see how we're adding 2 and we're adding 4 to 11 to get the spacing. Just like if you look at the even numbers, 12, 14, and 16. 14 is 2 more than 12. 16 is 4 more than 12. So the spacing is the same. It's because of how they fill in the gap with each other, evens and odds. So the setup for evens or odds is exactly the same. How do you know? Well, they should have to tell you. So if your answer comes out, if you were asked to get odd numbers and your answer comes out to be even, then that wouldn't work as a solution. Alright, so let's look at a problem dealing with consecutive. So the sum of 3 consecutive integers is negative 36. Find the integers. So the first thing I would do is just list out kind of the generic setup of what this is. 3 consecutive integers. So n plus 1, n plus 2. Now it says the sum of these. So sum refers to, again, addition is equal to negative 36. So we're going to add these 3 together, the first number, the second number, which is n plus 1, and the third number, n plus 2. And we should get an answer that is negative 36. Now notice these decorations or these parentheses are just there for decoration. They're not doing anything mathematically. So we can just add up our n's together and add our 1 and 2 together, clean up this side and make it look like 3n plus 3 equals negative 36. So now we just need to solve for n. So subtract 3 to get rid of the constant term. And then we're going to get rid of the coefficient. We're going to divide both sides by positive 3. And that will give us our first number is negative 13. Our first consecutive integer. The next one is 1 more than that. So if you add 1 to negative 13, you get negative 12. Notice when you increase negative numbers, you actually get closer to 0. Those are the greater than values. And then you add 2 to that n value, and negative 2 more than negative 13 is negative 11. So there's our 3 consecutive integers. Find 3 consecutive even integers such that the difference between 4 times the smallest and 8 is equal to 7 more than 3 times the largest. Find the integers. So looking at the first part of that, 3 consecutive even integers. So n plus 2, n plus 4. We said that's how you set up even integers. And we want the difference between 4 times the smallest would be n, and 8, difference refers to subtraction. So we're going to take 4 times n and subtract 8. And then that's going to equal 7 more than 3 times the largest. Well, the largest is n plus 4. So 3 times that, and then 7 more means add an additional 7 on top of it. So now we need to simplify that right-hand side of the equation. So distribute 3 times n, 3 times 4, gives us 3n plus 12. Add the 12 and the 7, combine like terms, and we get 3n plus 19. Now we need to get, so we only have letters on one side, so again I'm just going to get rid of that 3n, subtract 3n from both sides. That's going to give us n minus 8 equals 19. Add 8 to both sides, and we get n equals 27, which means our 3 numbers are going to be 27, 2 more than 27 is 29, and 2 more, and then 4 more than 27 is 31, which means our answer is no solution. Why is it no solution? Well, if we go back and look at the problem, find 3 consecutive even integers. Not odd numbers, even numbers. These are odd, so there is no solution to this problem. And sometimes you run into that. if it had said odd integers, we would have gotten the 27, 29, and 31. But since it asked for even, no solution. That can occur. You don't know that until you get to at least one of the answers. Alright, that's how you translate verbal expressions to variable expressions.